This lesson is for FST. This is lesson 9.2 on rational power properties. Students should only be using a baby calculator during this lesson. The focus of the lesson, just like the previous one, was on roots. So why do we need to learn them? Because root powers or root situations are the inverse operations of exponent problems. Exponent problems come up frequently in many different variety of situations, and so roots will undo those. What are they? Well, we typically write root problems in one of two ways, either in rational form or in radical form. So let's start with a problem that's in rational form. Rational is another word for fraction, so we're working with a fraction exponent here, so that would be considered in rational form. Typically we can't handle raising to the 3/5 power all at once, so we break up the fraction into two pieces. We take the 3 off of the top. When we do that, there is still a 1 left behind, so we could say that we could raise to the 1/5 power and then raise to the 3 separately. We could do those two pieces in either order, so know that we did it first here in root form, then we could do it again in power form. We could do the power first and then the root. Typically it will be easiest for students to do the root first. So I put the first two right next to each other because those are the two that I want students to focus on. When you raise to the 3/5, most likely you will do a 1/5 power or a root of 5 first, and then you'll raise to the power of 3. It's not wrong to do it the other way with the power first and then the root. It's just those tend to be more difficult. When you raise to a power, that number is going to get very large very quickly. And finding the root of a very large number can be quite cumbersome. So it's usually faster and easier for students to do the root first and then the power. Over here we also have the same things but listed in radical form. Remember that the radical is this symbol that looks like a square root. If there is no number listed, it's a square root. If there is a number, then that's the type of root that it is. So in this case, it's a 5th root of x cubed. The 3 is still a power, the 5 is still the root, just like it is over here in rational form. Keep in mind that if there are parentheses involved, here you would do the root first and then the power. On this one, you would do the power first and then the root. Before we get into some examples, we're going to look at additional properties of powers that we need to review from Algebra 1 and Algebra 2. Students should take a moment to copy all of these properties down, either from the video or from pages 570 and 71 in your FST textbook. When you're working with two bases that are the same and you're multiplying them, the result is that the exponents get added. Let's contrast that to when there's one base and you raise to 2 powers, there you're going to multiply. If you're working with more than one base inside parentheses and those are being raised to a power, you could raise to the power on each base individually. Students typically describe this property as being a distributive of the power, which is not entirely correct. It's like distributive, but it isn't the distributive property. The distributive property is when you take a number that's in front, that's being multiplied, and you distribute it to both pieces on the inside, and usually that happens when the two pieces inside are either being added or subtracted. We don't have that going on here. We don't have addition or subtraction, and we're not multiplying, we're raising to a power. So all you would really say here is that the n gets put with both pieces separately and then the parentheses drop. Similar to the first one, when you're multiplying, that turns into addition. When you're dividing, that turns into subtraction. So if the bases are the same, go ahead and subtract the exponents to simplify your answer. Let's contrast that power or that property now to the one below. Here, if you've got two different bases being raised to a power, that power can get put with each piece top and bottom separately. Keep in mind that when you raise to the 0 power, you always get 1. And don't forget, when you have a negative exponent, that will take the reciprocal of the base. Another thing that I want to look at with students before we try some examples is something related to the lesson previously, lesson 9.1. We referred to the fact that a rational exponent problem cannot have a negative base. And now that we've introduced some properties of exponents, I think now I can finally address the reason why. If we do the radical or the cube root of -8, -2 times -2 times -2 is sufficient. If we do it in rational form, however, we do not get a -2. And let me show you an example where that might be true. 1/3 is the same as 2/6. And from what we just talked about in this lesson, we can break up the 2/6 into two pieces, a power and a root, as separate steps. In this case, I want to do the power first. -8 squared is going to turn into +64, and the sixth root of that is going to end up being a +2, which we know is not the answer. We know the answer is supposed to be -2. So by applying properties here with a negative base, we get the wrong answer. So that's why we restrict, or we don't allow, negative bases when the power is rational. So that's just a follow-up item from lesson 9.1. Let's go ahead and try some rational property problems now. This is typical to what students will see in the homework and on tests and quizzes related to this lesson. Keep in mind that you will be only allowed to use a baby calculator, and you want to remember that no decimal answers will be allowed. Since we're taking 128 to the 3/7 power, I would break up the exponent into a root and a power as two separate pieces. So I'd have 128 to the 1/7, and then I'd raise to the power of 3 as a separate step. I don't know what that is by heart, so I'm going to do my first best guess. 128 is an even number, and I need 7 of the same number to multiply together to make 128, which is actually fairly low for multiplying 7 things together. So my first guess is that it's probably a 2. To keep track, I'm just going to tally as I record the results in my head. So I'm going to do 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64, 64 times 2 is 128. So I got my answer by using 7 2's multiplied together. So I know that the part inside the parentheses here is going to be a 2. 2 cubed is still left for me to figure out, and that's going to be 8. Common mistake there is for kids to say 2 times 3 to get a 6. Be careful that you're doing 2 to the 3rd power. Let's try another one here. This one's got a negative. The negative power I'd recommend that you do first, because many students who don't do it first forget about it altogether and then get the wrong answer. So the negative exponent here, if you remember the property, negative exponent will flip the base over or give you a reciprocal. So in this case, I'd want to flip this and make it 1/27. Now the negative on the exponent is gone. I'm also going to rip apart the 5 and the 3. I'm going to do the 1/3 first and then the 5. I'm going to take the cube root now of the top and the bottom separately. That's also one of our properties here. I'm taking the 1/3 and I'm going to do it to the top and the bottom as separate steps. So 1 times itself 3 times is still going to be 1. And then what times itself 3 times equals 27? That's going to be 3. I still need to raise both of those to the power of 5. 1 to the 5th is still going to be 1. And then 3 to the 5th I don't know by heart, but I have memorized that 3 to the 4th is the same as 3 squared times 3 squared. And I know that 3 squared times 3 squared is 9 times 9, or 81. So I'm just going to quickly calculate 81 times 3, because that'll be 3 to the 5th. 3 times 1 is 3, 8 times 3 is 24, so I get 1/243 there. So notice that both of these questions were somewhat difficult, but we were able to break them down into a root and a power and a negative and handle those pieces separately so that we were able to arrive at an answer. The next piece that I want students to look at is typical to what you're going to see in the homework. These are not homework questions, but they do mimic homework questions 7 through 10. What they're going to have you do is try to do a root, a single root, and then incorporate that answer in a more challenging fashion. So I'd like students to pause the video right now and give these a try, and I'll display answers and explain shortly. So you'd need a little bit of trial and error here to figure out what times itself 3 times equals 64, and you get 4 there. On the next one, we're going to incorporate that answer now, but first we're going to flip over the 1/64 because of the negative. Then I do the 1/3, which I know to be a 4, and then I still have to square that. 1 squared is still 1, 4 squared on the bottom is going to be 16. So 1/16 is the final result. Moving on to the next one, taking the 1/2 power is the same as taking the square root. So what times what is 64? Hopefully everybody knows that that's an 8. Now on this one we don't have a negative, so we're not going to flip the base over, but I am going to rewrite it as a 1/2 first and then a cube. Since I know that the 1/2 is already going to result in an 8, now I do 8 cubed, which is 512. 8 times 8 times 8. Now on the bottom two, they ask you to do them just kind of straight up as they are. First thing you'll do is flip over the base because of the presence of the negative. Then I'm going to do the root of 1/4 and then the power. The fourth root of 16 is a 2, fourth root of 1 on the top is still 1, and then I would need to cube that. That's where I got 1/8. On number 10, because of the negative, I flip the base over, and I'm going to do the root first and then the power. So the 5 got pulled off, and I do a 1/3. So the cube root of 1 is still 1. Cube root of 125 is 5. Technically, I need to do both of those to the 5 or to the 5th power, but I already know that 1 to the 5th is 5. Or excuse me, 1 to the 5th is 1, so 5 to the 5 is all I have to worry about on the bottom, which is 3125. I want to do one little for instance here. Let's pretend for a moment that number 10 actually started out as 1 over 125 to the negative 5/3. If you already have a fraction as your base and you're raising it to a negative, then your first step is to flip it over. So we would end up figuring out 125 to the 5/3 that way. So know that if you have a fraction, simply flip it over if you have a negative exponent. So we'd get the same answer as what we got for number 10, only it would be flipped over, so we would just get 3125. Another type of set of problems that I want students to try is when the book asks you to rewrite it in another form. Again, problems 1 through 5 here are not exactly like the homework, but they do mimic what the homework questions will look like. Quick reminder on what rational form means. You're taking a base and you're raising it to a fraction power. Usually the top number is the power and the bottom number is the root. So they're giving us a problem in radical form, and we're going to write it in the other form. So I know that r is my base, and then I got to figure out where the 3 and the 5 go. The 3 is the root, the 5 is the power, so the 5 needs to be on top, the root should be on bottom. Some students might say here that we would handle this problem by doing the root first and then the power, and you would be correct in that case. However, the one that's circled, the one on the left, is a more simplified version of the one on the right. So even though we would handle the problem by breaking it up, it is more simplified by putting the two back together. So do the same thing on number 2. The t is our base. We're raising to the 9 and we're taking the 4th root. So that means it's 9 over 4 as the power. The third example here has a decimal in the exponent, and we hadn't done any decimals yet. Keep in mind that when you're working with a decimal, you want to make sure that you say it correctly. Most people would probably just say 0.3 here, which is fine, but if you say it more accurately, you'll be able to see your answer more accurately as well. 0.3 is the same as 3/10. So if I rewrote this, I would say negative 3 over 10, which is the same as 3/10. Keep in mind that if the book says, rewrite it in rational form, no negatives allowed, then you would not be finished on this question. You'd have to do something about the fact that there's a negative exponent. The negative exponent will flip over the base, and now I write it as 3/10. You could also write this one so that the 3/10 was only with the k, because taking 1 and raising it to the 3/10 is still simply going to be a 1. So the most simplified version of this without any negatives is this answer here. The last two problems here just have students do the same type of thing, only writing it in radical form. It's in rational form, we just have to use the radical symbol to simplify. So you take your base, put a radical symbol in, making sure that the root, the bottom of the fraction, goes out front, not in front of the radical like this, which would indicate times. The 8 is a little number, almost like a superscript. And then the 7, you've got two options. You can either put it with the x, or you can put it on the outside of the parentheses. Either way is acceptable. On the last one here, we're going to take the base of x. I want to flip it over because it has a negative exponent. I'm going to take a 5th root of it, making sure that your 5th root is big enough to encompass the entire fraction. and then I'm going to raise to the 8th. Technically the 1 gets raised to the 8th as well, but 1 to the 8 is still 1. So x to the 8 there is my final answer underneath the radical.